How to decide about test of means? Is it parametric or non-parametric? I have reports from 500 students, and these students are from 4 states. I would like to compare doing homework hours per week among the students from these 4 states, so I need to do a test of means. I'm going to decide about the type of the test. Is it parametric or non-parametric? Do I need to run analysis of variance, ANOVA test, or non-parametric Kruskal-Wallis test? My priority is ANOVA, but the parametric test has some basic assumptions. Among these assumptions are 2 that we can test here. We can easily test for normal distribution of the samples. All 4 groups should show normal distribution and equal variances. The variances of these 4 groups should not be significantly different. So the first step is testing these 2. I'm starting with fit y by x platform. Doing homework hours is the variable we are testing, and the factor is region or state. Region shows the state of the student. So we have 4 stacks, and then from the red drop down, test of unequal variances is available. There are 4 different tests that are done. From these 4, I'm looking at Levine test. It does not require the normal assumption. The p-value of the test is very small, and that means the variances of those groups are significantly different. So one of the basic assumptions of ANOVA is not met here. ANOVA is not a valid test. And I need to do a non-parametric test, Kruskal-Wallis. I will go ahead and do a non-parametric test. First option, the menu says Wilcoxon test, and the screen menu says that if we have more than 2 groups, it will be Kruskal-Wallis test. During the test, we can see under Kruskal-Wallis, the p-value of the chi-square test of significance is very small. That means we have significant difference between the means of doing homework hours for these 4 states. So which one is on top? Go to the table of numbers here for Kruskal-Wallis test. State of Kansas, z-score shows 3.9, and then state of Iowa, and the sample z-score of -3.99, the lowest. Now, if this test determining that the variances are not significantly different, let's say the mean test p-value is larger than 5%. For doing ANOVA, we need to test for normal distribution of the samples. So we can run distribution for doing homework hours. Well, this is overall. We can test for different groups. I can add a local filter here and add region, which is the state, and then select state 1 by 1. Obviously, these distributions are not normal. If they're close to normal and you're not sure about normality, we can do a test of normality here by going to the drop down of the distribution and fitting a normal curve under continuous fit normal, and under fitted normal group goodness of fit test. Shapiro-Wilk test, p-value here is very small, which rejects the null hypothesis of the test. The null hypothesis is right here. Data is from a normal distribution. So the distribution is not normal. We can test it for all other states. As I select the filter for each state, all calculations are updated. And we can see that the p-value for all here for the goodness of fit test is very small. So samples are not showing a normal distribution. In case the results of both tests show that we have normal distribution of all samples and equal variances, then we can run ANOVA. Go back to fit y by x platform and means ANOVA. One-way ANOVA table is here. with the results, analysis of variance, and we can see that the p-value of the test for ANOVA, 0.15, indicates that we don't have significant difference among the means. The result of ANOVA is different from the result of non-parametric test Kruskal-Wallis. So selecting type of the test might affect the outcome. As we compare the means in the ANOVA table, there's not a very big difference among 4 states. So ANOVA indicates that they're not significantly different, but the non-parametric test, which works with the ranks, shows that the differences are significant. The conclusion: it's important to determine the type of the test means from the beginning. First, decide about the type of the test by testing for normality and equal variances, and then run the test, parametric or non-parametric.